have been doing well. My student scores between first and fourth period are higher than anybody's in the county or the majority of the county, which means you guys are doing it. I didn't, let you cheat on the test. You guys did that yourself. So whatever we're doing in this class for the last month has been working. You guys are being successful, okay? I will be putting your test grades in. We're finishing up our scale for how we're going to grade it. But for the most part, most of you did really well, okay? So what I want to see is on Monday, when we come in, we are going to do things a lot differently. We're not going to be walking around talking back. Everybody has been warned. The last time it's going to happen. After that, it's going to be So, what we are working on yesterday and today with these points is the building blocks for all graphs. So, I think I said it yesterday, but if not, I'll repeat myself. There's certain things that we do in this class. We do it like for one day, one lesson, and then you don't really ever see it again. It's not like something we do all the time. A couple things we do all the time, you already know, like solving an equation. We've done a ton of them. We have to get the variable by itself, what you do to one side, you have to do the other, the line you draw, all that stuff. The other thing is graphing. We have to do a lot of graphing in this class, and we're going to, and with graphing, it starts with just knowing how to plot the points. That's the first step. So if you don't understand how to plot the points, that's your foundation. You won't know how to do all the different levels of graphing that comes after it. So we're building on this, all right? So looking at these ordered pairs, let's just call them like A, B, C, D, so we can label them. And as a reminder, this is the coordinate plane. This is your x-axis. This is your y-axis. And we have 4 quadrants. 1, 2, 3, 4. That order matters, okay? This is always quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, we need to know that. Okay, so let me ask somebody. Let me see. So, Gabriel, do you know what quadrant -1, -5 would be in? 1. Yeah, so remember, x and y. We always do our x first, y second. X is left and right, y is up and down. We start at the origin. This would be left 1, down 5. Okay? So if it's a negative x, we go to the left, a negative y, we go down. Okay? Sylvia, do you know what quadrant B would be in? Fourth, yeah. So always starting here. A positive x, right 4, a -1, down 1. Okay, so that's quadrant 4. -3, 2. Max, do you know what quadrant that would be in? Yep, good. So x is negative, we go to the left. Y is positive, we go up. And that would be C, quadrant 3. Elisa, do you know where D would be? Yeah. So right 2, up 3. When they're both positive, you're going to be in quadrant 1. Okay? So really important that we know how to graph those. Okay? And then just like yesterday, I did some intercepts here. Intercepts are where the points are touching the x or the y axis. So all 4 of these points, because they have a 0 as one of their letters, will be on either the x-axis or the y-axis. Okay? So again, let's just do A, B, C, D. So just stay with the same order. X is -4. So that means I'm going to go left 4, up or down 0, right? 0 means nothing, right? It means 0. There's nowhere to go. That would be my first point. Just so you know, I think they left, but today was a big, you might have had them in your other classes. There's people walking around observing certain classes. They are supposed to come into the Algebra 1 classes. They didn't come into my first period. They might come in here. I don't want you to be intimidated by it. It's a bunch of people in suits. There's like 8 of them. I think some of them already left, though. I don't think they'll come in here, but if they do, they might ask you questions and stuff. Not math questions, but questions about the class. So just wanted to warn you that might happen. Okay, so this point, I'm at the origin. My x is 0. That means I go left or right, nothing, right? And then with a -4, do I go up or down, Gabriel? -4, do I go up or down? Down. So, Keisha, where am I going to go first with the C? Right. 1, 2, 3, 4. And then y is 0. Don't go up or down. And lastly, left or right 0, up 4. Jace, are you writing these? Okay. So as a reminder, so if you don't have any questions and you're done with this, feel free to put this away. You know, Monday is coming up in a few days. Monday's when I collect homework and bell work. So you guys have the weekend to make sure you have everything. So this will be on top. This will be on top of your notes and your homeworks from this week. Remember, I call it homework, but practice, okay? So go back, make sure all your bell work is done, your notes are done. And by done, I mean like you showed work. If I show work, then you should show work. There's no work to show her here. There's no work, okay? But there certainly was on this page and here. Sometimes in our notes, there's no work. Sometimes there is. If I'm writing it, you should be writing it, okay? All right, today's is going to be a little challenging for some people, okay? I'm always going to be honest with you. Like, this is an easier lesson, or this is a more challenging lesson. So I'm telling you right now, this is a little bit more challenging. Just seeing how first period did with it, so I need you guys to, like, really pay attention. So we should all be on page 282. Max, let's go. We'll wait for you. Come on, Gabriel, page 282. You got to get used to using the books, I know. Jace, you're on page 282, hon? I just can't see. That's why I'm asking you. I can see Miley. Okay. A linear function is a function that has a graph that's a line. A linear function makes a line. Okay? You don't have to write this. This is a line. This is a line. This is a line. It's continuous, and all the points are lined up like a line, okay? This is not a line. This is not a line. They're continuous, but they're not lines, okay? So lines are created from linear, so linear functions make a line. And so there's several, unfortunately, different forms that linear equations can be written in. And the first one is standard form, okay? So standard form of a linear equation, so I'm going to abbreviate it with SF, is AX plus BY equals C. Max, last time I'm going to tell you to put your hand up. AX plus BY equals C. And there's a few rules, okay? A has to be a positive number. A can never be negative, okay? And, you know, if you think about, there's two sides of the equation, right? Because what we're going to be doing, let me just jump ahead a little bit, is we're going to be given equations, and you're going to have to put it in this form if you can, and then you're going to say, yes, it's linear, or no, it's not linear, also known as nonlinear, okay? And so understand a couple, this is really important, this is the part people got confused about. A, B, and C are just numbers, okay? Those are numbers. You won't see an A, a B, and a C in the problem, ever, okay? A is the number that's in front of the X. B is the number that's in front of the Y. C is called your constant. It's the number that doesn't have a letter, okay? And we have left side of the equation, right side of the equation. So this is all about moving stuff to the correct place. Think back to elementary school. You had a line leader and a caboose, right? And those were certain places that you had to stand when you went to music or whatever you did, okay? Everybody in a linear equation has a spot they have to be in, okay? And that's what can be a little challenging for people to do. So let me just show you an example of an equation in standard form. So just to make sure you guys are clear, what I'm doing right here as part of the notes, this is stuff when I check your packet, I will look to make sure you were writing all this stuff down, okay? And I'm giving it to you. This is free points, guys. If you're sitting there, you might as well write it down. This is just part of your homework packet each week, is doing the notes. Okay, so this is standard form. This is written in standard form, okay? Look, this is your A value, AX. This is your B value, right? There's my equal sign. And this is my C value. See how the A, B, and C are replaced with a number. A is positive, as it should be, okay? One thing I will say, the B and the C can be negative. They're allowed to be negative, okay? So even though this says a positive and this is a positive C, they can be negative. It's only A that cannot be negative. And so what I want you to really notice is that X and Y are on the left side and the plain number that doesn't have a letter is on the right side, okay? So what we're going to do in our first example is simplify an equation, and then we're going to try to put it in that form, okay? So looking at this equation right here, there's some simplifying I have to do. We have 4x squared minus 2x, what the heck is that? So we have to simplify that. That goes back to our order of operations, okay? So I'm going to simplify 2x squared over here, and then I'll insert it back right here. So guys, those parentheses mean whatever's on the outside I do to everybody on the inside. It's like including everybody. So this squared goes to the 2, this squared goes to the x. So that's 2 squared times x squared, which is 2 times 2 is 4x squared, okay? So when you see an exponent on the outside of the parentheses, you do that exponent to everybody inside. So we just found that that is 4x squared, okay? Stop me if you have a question with that. Next, do I have to write you a pass to the clinic? Do I have to send you a pass to the clinic right now? Okay, then keep your head up. 4x squared minus 4x squared, guys, those cancel. They go away. You technically have 0x squared, but I don't like writing that, okay? So really, what we have at the moment is y equals, we don't need to write the 0x squared, 3x minus 5. Now, I don't like the way they do that. Let's bring it right over here. Y equals 3x minus 5. So here's where some students got confused. It's normal with this, is really seeing your two sides of the equation. Because now that we simplified anything that needed to be simplified, we have to get this in that order, okay? So I'm just going to write it here again so you guys can see it on my screen. I know you have it written above, so if you don't want to write that, you don't have to. Okay, so we want to put this in pink in that form. So think about it. We have a left side and a right side, right? Don't forget who is supposed to be on the left side, the x and the y. Well, the y is on the left side, but the 3x is on the right side. So we have to move the 3x to the other side. And you know how to do this already, even if you don't think you do. How do I take a 3x and move it to the other side? Keisha? Yeah, that's right. So subtract 3x, subtract 3x. And you can't actually do y minus 3x. That's not possible. So we just write it. And I know I'm going to put the x first because I'm trying to make it look like this one. So it does matter what order you put those in. Remember, you want your ax, your by. And then all that's left on the right-hand side is a negative 5. Right? That's what's left. Alan, you write this? All right. And we're really close to being in that form. The last thing we have to worry about is making our a value positive. And that's really easy to do. Okay? If you multiply something by a -1, it'll change its sign. So if I multiply negative 3x by by a negative 1, it'll make it positive. And you're allowed to do anything you want to this equation, literally anything you want, as long as you do it to both sides. So I'm going to multiply this side by negative 1 and multiply this side by negative 1. All that does, y'all, is change everybody's signs. Anybody that was negative becomes positive. Anyone that was positive becomes negative. Final answer, 3x minus y equals positive 5. So there's my A is 3. B is something. C is 5. What is B? What is the number in front of that y? Close. What'd she forget? Negative. Good. Yep. So, guys, if y equals 1y, then negative y equals negative 1y. We just don't write the 1 in front of it, but we know it's there. Okay? So, after all that work, do you guys think, yes, this is a linear equation, or no, it is not? Yes, it is. Okay? If you can rearrange an equation to look just like this, then it is a linear equation. Okay? Believe it or not, that was one of the easier ones. Okay? Let's look at another one. This one is a little bit harder, and I gave you one in your homework like this. You'll be able to match up the homework problems very easily with what we did in our notes. So that's another reason to do your notes, because you can go back and look when you have to do your homework, practice, whatever you want to call it. Okay? So determine whether this is linear or nonlinear. Okay? It's a mess, right? It's a mess. First thing we're going to do is simplify anything that can be simplified. Like, are there any like terms in here that we can combine? And the answer is yes. These two. 3x to the third minus 1x to the third, so putting these together, is 2x to the third, right? If you have 3 of something, you take 1 away, you have 2 of that something. Okay? So we simplified it. There's nothing else to do to simplify it. Again, I don't like how this is. Let's flip it here. Now I'm going to take that equation and try to put it in this form. So there's a lot going on in this equation, right? There's a lot going on. But remember, just think really basic. There's a left side and a right side. The only thing that's allowed to stay on the right side is the C value. This is my C value. So he's on the right side already. He stays there. If you're not a C value, you have to go to the other side. And we can do it all in one step. These are both positive, so I can just subtract them from both sides. So then I just have that 6 over there. That's what I wanted. Positive 6, so it's just 6. And guys, these are all not like terms. We have 2x to the third minus 3x plus y. Negative 2x to the third minus 3x, and then that's a positive y, right? That's how I need to put a plus. And that's it. That's all I can do. Guys, does that look like this equation right here? Does that look like it? Yes or no? No. There's no x to the third in this problem. There's no x to the third. It's very specific. This is x to the first. So if it were like that, if it was that, you'd say, yes, it's linear. But when that is thrown in there, nope, it is non-linear. Okay? Last example, and this is the easy one, really easy. And it's kind of a neat concept, okay? How do we tell if a word problem without an equation, if you just do a quick glance, there's no equation here, there's no graph. How do you tell if an equation, a table of values or just information is linear or nonlinear. Like, if I graph this, would it make a line or not make a line? So it's really actually a simple idea, okay? So looking over here, and you can just listen to this. I didn't want to go over it yet because it didn't apply. If the function values of a linear function change at a constant rate, it's linear. So let me put that in English. As long as your x values and your y values change exactly the same as you go through the table of values, it is a linear function. If there's any difference in the numbers, it's not linear. It's that simple, okay? Not in the middle of the notes. Selena kicks a soccer ball. The height of the ball after each half second is recorded in the table. We're going to determine if this is linear or nonlinear, okay? So whenever you see a table of values, x and y, we can call it input, output. You can call it domain, range. Max, go ahead and pack up your stuff for me. Sorry, guys. So, really, really simple, guys. Look. So this is the time in every half second that Selena kicks a ball. So look, this is 0.5, from 0 to 0.5. From 0.5 to 1 is 0.5. And this goes up by 0.5 the whole way, okay? The whole way. Let's see what's happening here. Between 2 and 28, the difference between those numbers is 26 feet. So, yeah, he can have it, because I don't want him to come back in here. At 0 seconds, your height is 2 feet. Why would that happen? How could it possibly be? Think about this. If she's kicking the ball, and no time has gone on, how can the ball already be 2 feet in the air? Somebody. I didn't even think about that. That's good, Gabriel. How about someone passes it to her, right? So I'm not sporty, so just bear with me, but someone passes the ball and it comes to you at 2 feet in the air. So the time that she's engaging with the ball is still 0 seconds, but it started at 2 feet. So I just wanted to get that out of the way. A lot of times our word problems start out as 0, 0, but in this case, 0, 2, okay? And so after 1/2 of a second, it's already 28 feet in the air, right? That's a difference of 26 feet. Well, let's see what happens after another 1/2 of a second, okay? So I'm going to do 56 minus 46, and I get 10. So we increased, let me put a plus sign there. We increased by 26 feet. We increased by, I won't put that in right, 46 minus 28. We increased by 18 feet. And we could keep going, but we kind of already have our answer. The minute these heights change and they're no longer constant, what's constant mean? Same, right, Sylvia? Stays the same. So if it was going up 26 feet, 26 feet, 26 feet, 26 feet, that would be constant. Already, it's not constant. So let me ask you, Yasmin, is this linear or nonlinear? Nonlinear. Let me take it another step for you guys, because you almost, we have to show work in math, right? But knowing what this word problem is saying, we could almost answer the question this quickly. Think about it. So here's the ground, okay? The ball goes up in the air. What happens eventually? What happens eventually, Delaney? It's going to go down. right? It doesn't keep going forever in a straight line. It's not linear. It has to fall at some point. So it's almost like without that, I could have told you right away it was nonlinear, okay? But mathematically, that is the reason. So recapping, our inputs, domain, x values, have to change at a constant rate, and so do our y values output range, okay, to be linear. Okay, so you'll see one of those in your practice as well. Questions on that one? All right, awesome job. Moving on to page 86. Advice again, circle the problems. Say it again. 4. No, there's 4. So page 86. Guys, I want you to write on that page 2.2 day 2. You don't have to write the word practice. You don't have to write the page number. It's on that page. And then whether you write them and circle them, or circle them only, or write them, but just help yourself so you know what problems I'm assigning. So remember, when I check this on Monday, those are the ones I look at. As always, a key is available with no work. No work, no credit. Okay, so you guys have to show the work. And I did one of every type in the notes. So I need you guys to be flipping to your notes as you work on the practice. I will come around and help. You can work with your neighbor. But everyone has something they can be working on. Okay. Can you see it, Alan? Yeah. Okay. Yes, Jace. Be quick. We've got work to do. Okay, so again, this is to check. This is not, if this is what you turn in, this is not going to give you credit. Okay? This is just for you to check. You're showing the work. And again, using these books, you're always allowed to use a sheet of paper if there's not enough room, but you also could put work up here. I will look for it, okay? If you put the answers just here, I'm going to look for the work somewhere, or you're going to turn separate sheet of paper in. It's up to you. You figure out how you want to do it. There's lots of little spaces that you could fit the work if you want to not have extra papers. Okay? Number 14, your first problem is just like the first example. Look at example 4. Don't just click. This is going to be negative, right? So you subtracted it. Then remember, you have to multiply everybody by -1 to make the A value positive. Remember? So, is this the original equation? Is that the original? Yep. So, who's out of place? Just this guy. So I have to move him to the other side of the equation. I get -2x plus y equals 5, okay? And we're really close to being standard form, right? X and y are on the left side, constant on the right side. But don't forget, the a has to be positive. So that's when I multiply both sides by negative 1. If you multiply somebody by negative 1, it simply changes their signs. And that's how I ended up. Is that linear? Sure is. Okay? I told you these were a little tricky, okay? They are. They're a little tricky. It's not in here. Number 17 is pretty hard. Um, 17 is pretty hard. I don't agree with some of these problems. I think they're dumb. Let's see. Okay, so guys, try and think simplistically, all right? It's hard when you look at this and you're like, what the heck is this? Why is she giving us this weird stuff? Start very simple. Is there anything I can simplify? Sometimes the answer is yes, sometimes the answer is no. But right here, remember we did one in the notes like this? I can simplify that. So 9x minus, and then when I do 9 squared, that's 9 times 9, I get 81. And when I do x squared, I get x squared. Okay? So I did the simplifying. Okay? Now, remember, I want everybody that's allowed to be on the left side to go there, anyone that's allowed to be on the right side to be there. The only thing allowed to be on the right-hand side is the 19. He's the number that doesn't have a letter, he's the only one that gets to stay there. If you're not just a plain number, you got to go. So 19 is going to stay there. The y gets added to the other side. How did I know to add? Because it was a minus in front of it. Opposite of subtraction is addition. And guys, can I add an x and a y and an x squared together? You can't. You cannot. So you're just left with negative 8. I'm just putting it in this order. I don't really care what order you put it in when it's a no. I mean, I'm hoping you guys know that because there's a 2 in here, it's non-linear, right? There's no exponent of a 2 in that form that we're trying to do, okay? So but this is technically the correct order. Put the biggest exponent first, and then the other two. Okay, so we simplified something that could be simplified. The only number allowed to be left on the right-hand side, right, is the C value. C is the number that doesn't have a letter. That's the 19. So the other guy had to go, minus y, plus y. So I added y to the other side, and I just rewrote that right here. That's all I did. I just rewrote it. And that would be non-linear. Yeah, Kishab. Good, very good question. Is it nonlinear because 81 is a negative? Well, not exactly. It's because there's an x squared connected to it. There's no x squared here. If that was all that was there, that would be linear, right? Positive 9x plus y equals 19. Even if we changed all these signs, Keisha, so if I multiplied both sides by -1 and made this an 81x squared, we don't have x squared in this form. Do you see that? So it's nonlinear. So I didn't even bother worrying about the signs. But Sally, did that make sense? The last problem is the easiest problem. I will tell you that. I just did 17 while you were gone, so I'm going to put that one. What's allowed to stay on that side? I don't care what order you write these numbers, okay? When it's nonlinear, it doesn't matter. Okay? If it's nonlinear, everything you move to the left-hand side, just put it there. You don't even have to worry about it. That's why I put two different answers, because it doesn't matter. Almost time. Almost time. Hopefully you finished quiz 4. Be ready to turn in your packet on